Okay, I came across this application and I thought that it was a really good one. It demonstrates a really clever way of using a quadratic equation to solve a problem. It also relies heavily on your ability to read and pick out the information that is necessary, and not only that, but decipher it the way that you're supposed to. So the problem itself says, an empty field on a college campus is being used for overflow parking for a football game. It currently has 187 cars in it. If the number of rows of cars is 6 less than the number of cars in each row, how many rows are there? So we have to think about what this problem is actually saying. So we have this football field here. So for example, something like this. And within this field, we have rows of cars. Okay, so rows. So this would be your rows, which I would term like your x value. And then when we're looking at it, this would be, say, like your y value. So the information that our problem is giving us is that, let's say x is going to be the number of rows that we have. Well, we are told that the number of rows is 6 less than the number of cars in each row. And so here that would tell us that if we're using, say, y as our other variable, that we would have y minus 6 to be the number of rows. Well, then that would mean that y is going to be the number of cars per row. So when we're looking at this, one of the things that we have to look at is the fact that our cars are blanketing our football field. They're covering it. Which means if we look at the number of rows times the number of car per row at the current moment, that should come out to being 187. Now with that, we know exactly how to calculate what's necessary. And so here, this would end up being y minus 6 times your y is equal to 187. So we can set up our quadratic. So this becomes y squared minus a 6y minus that 187 equals 0. So notice what I did is I distributed the y through and I moved that 187 over. We then need to solve. So in doing this, we set it into its factors or use whatever other means necessary that you like. This is going to split into y and y. This back sign here tells us we're going to use positive times negative as my signs. So I have one positive, one negative. This front sign here tells us that the bigger factor is negative. And then I need factors of my 187. That will give me negative 6 as a result. So in that case, we're going to have 11 and 17. So here we're going to go ahead and solve. So in this case, we're going to have y equals negative 11 and y equals 17. Now we're talking about number of cars, so in this instance you cannot have a negative value there. Therefore, y is going to equal 17 cars per row. Now the question wants to know specifically how many rows there are. So when we're talking about how many rows there are, we have to plug this in. So then here x is going to be 17 minus 6, which gives you 11. So therefore the answer to your problem is that there are 11 rows of cars on the field. So that's all that there is to that. It's just being able to recognize what exactly is it that the problem is doing, what is the information telling you that's been provided, and how do you put it together in order to solve. So if you have any questions, please let me know. Otherwise, I hope you enjoyed, and I'll see you next time.